Okay, so you have the green piece of paper, and basically you're just going to copy the green piece of paper into your notes, just so you have it. And we're going to talk about this real quickly. Okay, so all of these shapes have four sides. They're all quadrilaterals. Okay? Now, two pairs of opposite sides are parallel. Okay? Well, a parallelogram, that's the definition of a parallelogram. All right? And then a rectangle, rhombus, and square all have opposite parallel sides. Two pairs of opposite sides are congruent. That's going to be these four right here. Okay? The two pairs of opposite angles are congruent. Opposite kind of diagonal angles, okay, they're congruent. There's going to be also these four right here. All pairs of consecutive angles are supplementary, meaning they add up to 180. Consecutive means the next angle, as if you were walking around the shape. Also these four. Diagonals, the actual lines going from corner to corner, bisect each other. That is also these four. In other words, the diagonals cut each other in half. Now, four right angles. Well, that's a definition of a rectangle, and it's a definition of a square. The diagonals are congruent. That is only these two, the rectangle and the square. Four congruent sides, that's the definition of a rhombus and the definition of a square. The diagonals are perpendicular. In other words, they form a right angle, 90 degrees. That is only the rhombus and the square. Diagonals bisect, cut in half, a pair of opposite angles. Okay? Diagonals bisect a pair of opposite angles. That's also just these two. Now, one pair of sides is parallel. That's the definition of a trapezoid. And an isosceles trapezoid falls under that. The base angles are congruent. That is only an isosceles trapezoid. Two pairs of consecutive angles are supplementary. That is the trapezoid and the isosceles trapezoid. And non-parallel sides are congruent. That is the definition of the isosceles trapezoid. So the two sides that are not congruent, that are not parallel, are equal. That's the isosceles part. Okay, so looking at these, what do we have? Well, here we have just four lines. That is simply just a quadrilateral. And a board that is not cooperative. So that's just a quad. Now here we have four sides marked equal. So look at your chart. Four equal sides. Okay, what are we looking for? And that's the definition of a rhombus. Okay? Notice here, we have four right angles. That's all we have, just four right angles. So it's either a rectangle or a square. But since we don't know anything about the sides, all we can say is the rectangle. Now here we have four right angles and four sides marked equal, so that's a square. All we have here marked are parallel, okay? Opposite sides are parallel. All we know there is the definition of a parallelogram. And you can write out the word. I'm also okay if you just do this. Parallelogram. Now here we have two parallel sides and two non-parallel sides which are equal to each other. So that's the isosceles. I can write. I can't erase though apparently. Let's try this again. Isosceles. Just not writing very well. Actually, we're just going to abbreviate. Trapezoid. And here we have one pair of parallel sides. All we know that is a trapezoid. All right, so here's how the family tree of four-sided figures breaks down. You have two main sides. The left side here, everything is parallel. Okay? Both sides are parallel. Over here, so we have two parallel here, and here is one parallel. That's the main breakdown. On the right side, you have trapezoids, and then isosceles trapezoids. Okay? So let's do this. Let's mark these. Here are parallel sides, so let's mark those. Okay? And that's all we know. Here we have parallel sides, but we also have equal legs. The non-parallel sides are equal. All right? Now here we have a parallelogram. Okay? Opposite sides are equal, opposite sides are parallel. All right? Underneath that, you have either a rectangle or a rhombus. So once we get to a rectangle, we have four 90-degree angles. Opposite sides are equal. I guess we should have changed this up here. And we also have parallel opposite sides. Lot to mark. And this is going to be hard over here. I'll just put it on the outside. Those are opposite sides. Now the rhombus, still underneath parallelogram, so we know the opposite sides are parallel. That's important. We also know the four sides are all equal. Same size, same measurement. And then we get down to the big daddy, square, the perfect parallelogram. Okay? Right angles, opposite sides parallel, and everything is equal. You need to hit pause, go ahead. And now we got some graphing problems. So let's put these dots on our graph. So 3, 4. 1, 2, 3, 1, 2, 3, 4. That's D. And then 8, 6. Go right 8, up 6. There's E. And then 9, 9 is right here. So this is D, E, and F. Where will G go to be a parallelogram? Okay? So, we have this side here. Okay? From D, we need to have the same, they need to be parallel. So they're going to have the same slope. So if I count this slope as 1, 2, 3, and right 1, then if I go 1, 2, 3, and right 1, and put that there, and then I connect them, I will have a parallelogram. So where did I put my dot right here? That would be at 4, 7. That would make a parallelogram. Okay? Let's try this one. Graph A, -4, -1. Right there. B, -5, 4. Right there. C, 5, 6. Right there. And where would D go? So again, if I drew a line here, I need over on the right side to be parallel. Okay? But I also need the slopes to be opposite reciprocal because they need to be 90 degrees. So I need a 90-degree angle. So I need to figure out what the slope is between B and C. So if I count the slope, it's going to be up 1, 2, right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 over 10, which is 1 over 5. The perpendicular slope to that would be negative 5 over 1. Let's see if I got that. 1, 2, 3, 4, 5, 1. Yes. So I'm going to go from here at C, go down 5. 1, 2, 3, 4, 5. Right 1. And now I know that I have opposite sides parallel, same slope, and 90-degree angles. So where is that? That is at 6, 1. And that's it.